That's fine. People work it out.
That's a problem for post-production.
Yeah. I'm not sure we have post-production when it's live.
Okay, so hello everyone. Welcome to Mobile Dorset. Thanks for coming, and thanks for having me to do a talk. Quite excited. So, who am I? First of all, my name is Matt Wilson. For those of you who don't know me, this is my Twitter. You can tweet me questions if you have anything at the end, or feel free to ask questions during the talk. Bit of background about myself. I'm a web developer at a company called Sensei, based in Southampton. We do a web-based analytics tool, basically predicting failures in machinery before it goes wrong to prevent expensive downtime in kind of industrial settings and so forth. But crucially, I want to make the point that I'm not a mobile developer, although I do like coming to Mobile Dorset. I'm primarily a web developer. That's my background. So anything I say that is clearly wrong, please heckle, teach me things. But this talk is really trying to get across my experience with a tool called Nativescript, which is from the perspective of a web developer. So I want to start by talking about the various approaches you've got to build a mobile app at the moment. So I need a mobile app. How can I do this? The first one is obvious. The first one is I can build a native application using either Java, Swift, or C#. For the Windows people in the room, are there any? This is obviously, in the right setting, quite often the best thing to do, but it's not the only way. There are also things like Xamarin, which is quite popular. This allows you to build both Android and iOS apps, but using C#. So if that's your thing, maybe it's an easier way in. And there's also Xamarin Forms, which lets you build one code base and target both of those platforms. It's not something I know much about myself, but I know some of you do. So if anyone's interested, you can probably chat amongst yourselves about that one. The other way you can go in is you can just say, well, I'm going to build a website, but I'm going to kind of make it mobile first. It stretches as you go on a phone, and it looks and feels okay-ish. Which, if you're doing a simple app, might be okay for you. Then we have progressive web apps, which we'll talk about recently, which is kind of interesting and is gaining a lot of ground as well. It's kind of using web technologies, but adding APIs to mobile browsers that let you access more native features and so forth. Then you can use what I'm calling a WebView-based tool, such as Cordova, Ionic, Framework 7, Onsen UI. These are all kind of, they create a native application, but what you're actually running inside that is a WebView. So it's a website running inside the frame of a web browser, effectively. These are quite useful if you've got a lot of web experience, but they're kind of limited in the performance side. Some of the capabilities maybe aren't quite there, in my opinion. But I know a lot of people have a lot of success with it, and I've used it a little bit in the past as well. And then finally, we have what I'm terming web to native, which is where you're writing with web technologies, but you're actually, what comes out the other end is a fully native application. So React Native is an example of this. There was a talk recently, and I would also talk about this, and I thought it was really interesting because it was from the perspective of, I'm a native mobile developer. These are the things that I do or don't like about it. And I found myself thinking, well, some of the things that were said as bad things, for me as a web developer, are good things. And it's kind of what I thought would be interesting to explore as well. And then Nativescript is very similar to that. That's what I'm going to cover today. And there are two kind of flavors to it. There's you can write Nativescript with JavaScript and plain JavaScript, or you can use Angular and TypeScript, which is a kind of different variant of it. They both allow you to do the same sorts of things, just in a slightly different way. And I've kind of gone down the route of the Angular approach for this talk. So just a bit of information about the tools that I'm going to talk through. So first is Nativescript. And this is a cross-platform framework for building mobile applications. And what you get at the end is a fully native mobile app. So there are no web views. It's using things like JavaScript, but building a proper native app. As I mentioned, there are two different flavors. And if you go and look at the documentation, it explores both options and so on. As a web developer, I have used Angular quite a lot. So for me, that's the natural choice. And I also love TypeScript, which I'm sure some of you know because I wrote around about it a lot. We'll come to that in a minute. So Angular, for those of you who haven't used it, is a framework for building applications. So it was traditionally built for web applications. You can now build for mobile with it using things like Nativescript, and you can build for desktop using Electron and other tools like that. And what it basically gives you is a whole bunch of good stuff, building applications. So how can I put things on the screen? How can I move them around? How can I get data in and out of that? How can I manage state and get things from external resources? How can I fill out forms? All that kind of stuff that you would need to build any app. And Angular is kind of it's quite a big framework. It's quite a steep learning curve, but it does give you a lot of stuff out of the box. So I think there are good and bad things about that myself, but we'll go with that. TypeScript is a superset of JavaScript, which basically gives you static type checking and things like that on top of normal JavaScript code. But crucially, it's not a replacement for JavaScript. It sits on top, and what you get out at the end of that is normal JavaScript that runs in any browser or on the device in our case. It gives you, as I've pointed out here, it gives you the latest JavaScript features. So all the good stuff from ES6 or ES 2015 will work with TypeScript as well. And it's also able to understand your code a lot more, so it spots errors at design time that you wouldn't normally find if you were running in JavaScript necessarily till runtime, which is really good. And it makes your IDE come to life a lot, which is why I like it as well. And crucially, what you get out, as I say at the end, is standard ES5 JavaScript. Firebase is something I'm also going to go quickly into, which is a platform provided by Google that gives you loads of good services for building the backend for a mobile app in particular. And so what you get is things like a real-time database, which you can use to synchronize data between different clients. It gives you tools for authentication, so logging users in and out, managing different user accounts. It gives you storage options, so you can store files and then upload them and download them from apps without having to kind of provision any kind of infrastructure for yourself. So it's a very good tool for building something quickly, and it scales well as well. And a whole bunch of other stuff. I recommend you go and have a look at it if you're interested in the kind of the back end of building these sorts of things. It's quite a powerful set of tools, and you can get quite a lot for free as well. So everything that I've used is free. So with that in mind, that's the kind of tools I want to talk about. But first of all, how can we get started with it? So what do you need? You need a code editor, obviously. My tool for choice when I'm doing Nativescript has been VS Code, which is a great open source free editor. It's kind of similar to Atom in that kind of type of editor. And there's loads of great extensions and everything for it as well. You'll need Node and NPM, NPM in particular, to pull down a lot of the tools that you'll use. Nativescript CLI is one of them, and that gives you all the tools you need to create your application and run it up in various emulators or devices. If you want to build for Android, you'll need all of the Android SDK tools, just like if you were building a native app. And the same for iOS, you'll need a Mac, you'll need Xcode and all the various dev tools that you'd normally have. And then if you want to use Firebase, you just need a standard Google account. You can sign in for free and start using this stuff. It's quite easy. And if you do all of these things, what you get is the ability to write a single code base and target both Android and iOS. You get all the good stuff that you'd expect from modern tools. So you get all things like auto-completion, things like live reloading, and various debugging options, which I'm not going to go into too much detail, but it's quite powerful and more powerful than some of the other things I've used, especially like Ionic, for example. I found it a bit difficult to debug and find out exactly what's happening. Whereas with Nativescript, it's quite tightly integrated into either the Chrome DevTools or your editor. So in Visual Studio Code, there's an extension that lets you, set breakpoints, move through your code and all that stuff. And so with that in mind, let's look at how we actually create an application to start with. So you just literally say tns create, my app is called whatever. And in this case, I've passed the ng flag, which says I want to use Angular. Next thing you can do is TNS run, and then the name of your platform. And this will go and create a native app in that platform, build it, run it, and bang, you're good. You can also run the TNS debug, which gives you the same thing with all the library loading goodness, but with also the debugging capabilities attached.
Would that launch like emulator?
It will launch either an emulator or if you've got a device plugged in, you can run it on another device. So what you'll get at the end of this is an application folder, which I'm going to just show you an example. I'll switch over to, this is Visual Studio Code if you've not used it. And it creates a kind of fairly standard looking structure. And just to point out a couple of the key parts here. We have a package.json file, which if you've ever worked with NPM will look familiar. It allows you to specify all of the dependencies that you need in order to run your app. All the tools that you need during development, so things like compilers or code linting tools, that sort of stuff. And then you can specify scripts, which just make it easy for other developers to come in and run your app or run a particular part of your build chain and so on. If you've ever done NPM, that's kind of standard stuff. In the app folder, we have the actual application itself. So this is where you build up all the parts of your application, all your source code, and so on. And then the platforms folder is where it gets interesting. So what you get out is something like a standard Android application. So this is something you can open in Android Studio. You can build with all the normal tools. And the same with iOS. You get an Xcode project, which for the natives amongst you will look familiar as well.
Quick question. TNS, what does it stand for?
Sorry, that's Telerik Nativescript.
Telerik.
Yeah. I think there's another alias for it as well, but that's the one I've used. So these folders inside platform, it's quite important to note that they are automatically generated for you. You never really need to go in there and touch them. But what you can do, if you want to specify something that needs to go into your native folder, is inside app resources in the app folder. You can specify different resources that you need. So you can say, I've got this image I need. It's for Android and all of its different scale sizes for iOS. And it kind of works like a delta. So those files will get automatically bundled into the right place in each of the different platform folders. Which is quite nice because that means you don't need to care what's coming out the other end. It's just, you just work with your resources and that's it. So what I've done is, I go over here, I've created a little example app just mainly to learn it myself and for the purpose of this. So you can see I've got the iPhone emulator on the left, Android emulator on the right, and it's running the same application. I'm hoping that if I click this, it will work. There we go. That's signing into Firebase. And what you get is a list of events. So in this case, I've just gone with what kind of things might we have for a mobile Dorset app. So we might want to know when the events are going to take place. And I'm going to do the same actions on both devices just so we can see the similarities and differences really. And so you can choose an event, you can see what time and date it's going to take place, what the talks are going to be on that event. And crucially, can't really see it here because my dock is enormous. Let's see if I can hide this. There we go. Crucially, it's automatically, I didn't need to do anything, it's obeying the kind of native look and feel things like the tab bar at the bottom is on the top on Android. So it's kind of out of the box, gives you some of those things that make it feel correct to each of those users of those platforms. And then we have a lean coffee tab, which the idea being that we could specify, well, I suggest we talk about this particular thing, and then everyone can vote on those topics. So if I create an event over here on the left and say, hello, then it's going to go upload that to Firebase. And because the Firebase has got this real-time syncing magic goodness, it should arrive on both devices straight away, syncs really quickly. And if we vote for hello on the right-hand side, it's got a 1 on the left-hand side, and so on. And then you can do things like you can sort and so forth. But that's kind of the example app that I put together, and I learned quite a lot just from building something small like that. But what struck me is that there was very little need to worry about the platforms. It was quite easy coming into that from someone who doesn't necessarily know the ins and outs of those platforms. In my case, I've done a little bit of Android development, but no iOS. So to build that and have that done in one go is great for me. So going back to this, that's a bit of an example of what you could build with it. So now I'm just going to try and fairly quickly whiz through different aspects of how you'd actually build this. The first thing is, like I say, you're using web technologies to build all of the parts of your application. So JavaScript is a big one. CSS is used for styling, with a little caveat, which I'll come to in a minute. And XML, I've put XML, not HTML, because technically there is no HTML. It's not a web view. There's no DOM. You're not building divs and spans. And we'll see in a minute that you can use an XML structure that feels like you're building HTML, and it will come out with native elements. And as I mentioned, you can use NPM, which if you're a web developer like me, is familiar and great, and you can pull in libraries like Moment.js and Font Awesome and things to use the same sorts of tools that you're used to using. So if you've ever done any Angular, you'll know that you build your applications using components, and this is similar in React as well, and Vue. And so what you do is you build a list of a tree of components that nest inside each other, and each one has a specific inputs, so you can send data into the component, and outputs, which let you get things out of the component. And they have a particular life cycle which you can hook into, so you can say, I want to do this particular action when this component is mounted, and all that kind of stuff, which I'll come on to again in a minute. So a component is basically just a standard class. Now, I'm using TypeScript, so there'll be some bits in there that if you have done JavaScript and not TypeScript might look odd, but I'll come to those. But essentially all you're doing is you start with a standard class and you just decorate it using various annotations, which are provided by Angular. And in this case, we've got a component decorator, which is just saying, I'm creating a component, this is its name, this is its template file, and this is how it's styled. You can pull in your own models. So TypeScript gives you strong typing in the sense that you can say, I've got a model, it's got these properties, and I want to use it for my app. And I've specified an input, which is the topic component can be provided with a topic, and then we can go and render that. And then you can specify outputs. So let's say if you tap on that topic, you might want to say to the parent, a tap has taken place. And then finally, you can create your own functionality. So in this case, I've said, whenever the thing is tapped, send something on the output. So that's kind of a basic component. With that in mind, we need to know how we could go and create the actual view elements that make up your user interface. So this is technically XML, but you can, for all intents and purposes, think of it as you're building something that's quite like HTML. So in this case, I've created a button element, and I've given it some text, and I've given it an event, which is tap. So the round brackets, again, might look odd to you. This is an Angular thing. So what you can do with Angular is you can say, I want to bind the launch method to whenever the tap event is fired. I'll come on to that in a minute. But crucially, we've declared something as a button. And what you get out is you get a native Android button or a native iOS button. So there's no compromise. It is a real user interface element that just the same as if you were building it natively with Java or Swift or whatever. And they look and feel like a button. And as I say, no web views, which is key. So now that we know how to create an element, we need to know how to build a layout and how to move things around and store them on the page. So there are quite a few different options here, which I'll breeze through. The first is a stack layout. So you just say, I want a stack layout and I want it to go vertically. And then you place your elements inside, and that gives you elements stacked on top of each other or to the side of each other. There's a wrap layout, which is very similar, but that lets you kind of define elements that wrap when you get to the end of the page. So if you're doing a grid of images, this might make sense. There's a grid layout, which is quite powerful. So this is if you want to do something that's quite tabular. You can say, I've got these columns and these rows, and then place things in the different cells. And the stars allow you to do kind of weighted values. So you could say, I need 1/3 and 2/3 or something like that. And there are also options for saying just fill the space you've got and so forth. There's an absolute layout which just says I need this thing to be at this position. It's fairly straightforward. There's a dock layout. I need this, let's say you need something to be stuck at the bottom of the page, you could use that. And then there is also a newer part is you can use Flexbox. Hooray! I haven't actually got a slide on Flexbox because I didn't get around to playing with it. But just know that it's there and it's awesome. And Chris has already been selling Flexbox today, so I'm sure you're all sold. The next thing is data binding. So we've made some elements, we've laid them out nicely on the page, but how do we get things in and out of that? So with Angular, there are a few different ways to do bindings, and they all look a bit weird at first, but bear with it. So I've created a car in this case, and maybe I've got an array of cars, which is called cars in this case. And you can use the ng4 structural directive, is what the start ng4 is giving you. And that will create a car element for every element in that array. So it will just go through and spit out, let's say, 3 or 4 car view items.
Was this Angular 2?
This is Angular 2, yeah. Although they now say just call it Angular. Because it's just got a whole story in itself.
So there's no ng.
This is the new ng repeat, yeah. Basically, Angular 2 and onwards is now called Angular. And they've said just call Angular 1, or AngularJS, and it's all a bit confusing. It's going to be less confusing in 5 years when everyone's forgotten about Angular 1. But for now, it's weird. And let car of cars, if you've done any ES6 or ES 2015, whatever you want to call it, that's a new loop construct, newer than something in something, which is confusing as well. But, hey, so this is going to create a set of car view elements. And then you can pass in each one. So in this case, I've got the car variable from my loop, and I can pass that into the input, which I've called model. So that car, each car is given the one it needs to represent, if that makes any sense. The square brackets always mean it's an input binding, which is something you get used to quite quickly. And then finally, with some round brackets, you can create output bindings. So when any of these cars tell me that they've been tapped, I can call whatever functionality, so in this case, beep. I probably didn't explain that very well. I found it a bit difficult to think of a good example that isn't going too detailed, but that's basically the 3 main kinds of data binding options. So with that in mind,
So you had tap as an output. Yeah, an output. Other like tap, is that just one that's built into the framework?
Yeah. So tap is built into the framework.
Yeah.
And you get all the other things you'd expect. So double tap is one, and long press is one, and so on.
Yeah.
But if you're building your own components, you could specify your own outputs as well. So I could create an output called something exciting happened, and just put that in round brackets. And then whenever that component tells me that that event has happened, I can look into it. But yeah, that's a good point. Tap is just built in. And again, I've used long press in here. So if you long press on one of these, then you get an option to do stuff with it. So there's various options.
With those events, are they available up the tree, or is it only available to its immediate parent?
Generally, you would raise an event in, let's say you're 3 levels deep, you'd raise that event and then you'd catch it at the next level and pass it up again if you need to. So the idea is that you have this one-way data flow where you start with your data, you pass it down and down and down, and then events might bubble back up again.
You have to manually set up that problem.
Yeah, generally, yeah. You can do things like you can raise a global event and stuff like that.
Right. Okay.
But I think generally you would probably try to just compose your components so that they go up and down the tree, and that makes it easier to understand how your data flows around. So that was components. Now maybe I'll just show you a quick example if I can remember where I've used that in code. So in here we've got a topic component, which looks, as I showed you a minute ago, it's just a class, and it's got it's provided a topic, which is an input. So each one of these topic components, you can create a topic component, pass it your individual topic, and then it can go and render that using whatever view you need. So in this case, I've used the stack layout that I showed you, and inside that stack layout, I've got a button and a label, which is this button here, and the label to the side of it. You can use more complicated structures, like if we look at the event overview. Sorry, I've broken this. The event overview is a little bit more complicated, so that's this this tab here where you've got a kind of grid structure in the middle, and then you've got things stacking on top of it. So in that case, I've got a stack layout as the outer layer, which just says I want these things going down the page, and the grid layout inside that allows me to nest different types of layout inside each other. And then here I've got, for example, the text input binding, which is the square brackets I showed you a minute ago. So that's passing the current text from that item into the label in this case.
That's passing component to component.
Yeah. So in this case, it's just passing it into the label, but the topic list would be a good example of that. So here I'm creating what I call a topic, which is the box for one individual topic. And I'm passing in the event ID and the topic inside. So there's kind of a nest of components, if that makes any sense at all. I hope it does. Styling then. So we've got some things on the page, we've got some data in. So how do we make it look good? And the answer is I don't know at all, because I'm terrible at that, as you can probably gather. It's similar though to just standard CSS for the web, which is good news for me again. What you get is a subset of CSS syntax. So it's not CSS because there's no DOM, so we can't use normal CSS. But what they have done is they provided a lot of the standard CSS syntax and CSS kind of properties. The Nativescript people, yeah. Angular will run in all different environments. So if you're using Angular on the web, you would use normal CSS. If you're using Angular with Nativescript, then because there's no DOM, you need to use their subset.
Like position absolute won't do anything because all the layouts handled by the native.
Yeah, exactly, and that's why it's just a subset of those things. So what you do get is things like background color or a line left, a line right, that kind of basic stuff, and margins and padding and all that stuff will work as well. And what you also get, which is quite neat, I think, is the ability to say, I want these styles on Android and these styles on iOS. So if something doesn't automatically look good, which in my case, I haven't really done anything specific, it just kind of follows the platform conventions. You do have the options to dig in there and make it a bit more specific.
So like a common one as well.
Yes, yeah. So you can specify a chain of them. So you can say, I want this common file, and then I want this one which happens to have .android in the name, and it will automatically switch a route, which is neat. You can do that for images as well. So if you've got an image and you want it to be different on each platform, you can just name it .ios.png, and it will magically resolve, which is neat. So this is CSS, nothing special, and it works. And under the hood, it will apply those to the native UI elements and do whatever you need to do on that platform to make it work. That's styling. The next thing is how do we route and navigate around different parts of the application? This is where it gets a bit more fiddly, I think. What they've given you in Nativescript with Angular is they've built on top of Angular's existing routing capabilities. So Angular has quite a powerful router already, and Nativescript have added on things that are more mobile centric to that. So things like on a mobile app, you need to be able to go back and forwards in different ways on each platform. So the router that they provide will deal with that for you. We've got an example of that. Here we go. So interesting. There we go. So as you can see on iOS, you get this events back button in the corner, as you'd expect on an iPhone. On Android, it's not there, and you can press the native back button to navigate back, which I've pressed too many times in my haste. Sorry about that. Yeah, so how do we do this? It's quite simple, really. All you do is you say, I've got these routes, and they've each got a URL, if you like. So in this case, I've got login events and events / whatever ID. And then you just specify, when I go to this route, I want to render this particular component. Or when I go to this other route, I want to render a different component. So you get these kind of page level components, and then you can nest more components inside them. In this case, I've just got one weird one at the top, which is whenever you land on something where there's no, the empty route, then redirect off to the default page, which in my case is the events list. We also have the router extensions thing. Now, I'm not going to go into details on how this gets injected, but Angular provides quite a complex dependency injection system. Hello? No problem. Help yourself to pizza. Yeah, so Angular provides the ability to inject, using dependency injection, this router extensions thing. And we can then use that to just say, I want to navigate to /events. And these are all the routes that I provided a minute ago. That's basically how you can, say, navigate from here to here. And you can also do that in the markup like a hyperlink, effectively, and say, I want to go to this particular route. And the final thing to note, final thing to note about routing is this thing called a route guard, which again is an Angular thing. And this is handy for doing kind of checking things, checking your authorization in my case. So you can specify what I've called an auth guard. And you can then say, whenever someone tries to activate this route, check these conditions are true and only allow this route to be mounted if those conditions are true. So in my case, I'm checking it has the user logged in which case carry on all is good. Otherwise, take them straight back to the login page. So there's quite a lot of flexibility there. And this is all, if you've ever worked on the web, probably quite familiar. I don't really know the equivalents in native. But yeah, middleware, I guess, it's a similar concept in that you're kind of placing this piece of logic inside the chain. You can break the chain like you would in a piece of middleware. Life cycles. I'm going to need to drink for this. Obviously, life cycles are quite important, especially for mobile apps. As anyone who's ever built a mobile app will know, you spend a lot of your time worrying about when do I load, when do I chuck things away, how do I manage my memory, all that stuff. In Nativescript, you have options, many options. You have these three options. So first of all, I mentioned a moment ago the component lifecycle. So each component can specify things that will happen at different points. So when the component is drawn or thrown away, do these things. When my input data changes, do these things, and other things like that. So for example, I can say whenever the component is first drawn onto the page, I want to go and fetch some data from somewhere, and do these things with it, and then put it on the page. I'm not going to go into that too much. It just kind of is what it says. But sometimes that's not enough. Sometimes you need to know that what happens if a phone call comes in or the user goes off and does something else. So you also have the ability to hook into more application level things, like the user has suspended the app and gone off somewhere else, or they've come back, they've finished their phone call, we need to load everything back in. So if you need to do those kinds of things, Nativescript provides events for those that look a little bit like this. You can just say, whenever my application is suspended, do these things. And that is a unified kind of event that will get raised on whatever platform. So you don't really need to worry about the difference between an Android activity and an iPhone, whatever the equivalent is. As you can tell, I don't know much about iOS. If you need to, though, you can use args.android to know that you're running in Android and do something specific, which I think is kind of a neat way to do it. You can go to whatever level of depth you need to, but by default, everything is unified across the platforms. The third one is even deeper than that, is I need to use my Android lifecycle's particular hook. So the activity has been created, and there are events that will get fired for you for that as well. So in this case, if my application is running on Android and I've created an activity, you can do a thing. I'm not sure why you would really need to a lot of the time, but it's nice to have the option. And that's lifecycles, hooray. That's most of, I think, what you need to build a fairly what I'll call boring app. So something with data that shows and you can press on it and so on. But the fun stuff is, with a mobile app, obviously, is the things like use the camera or use the location services and that stuff, which is where I think the traditional web view kind of technologies fall down a little bit. But Nativescript is quite neat for this. And what they give you is what they call modules, which is basically a set of plugins that you can use to do particular native-like functions. In this case, I'm going to use camera as an example. And what they give you is a common interface, in this case, a TypeScript file, which says, there's a module called camera, and it has a function take picture. And that means that as a developer, you don't need to worry about the different ways that that happens on each platform. You just use this camera module. And whoever wrote that module will have specified how does this get implemented on Android and how does it get implemented on iOS. So I'm going to dig into the code. I'm going to go to the node modules folder, which is just where all your dependencies live. If you're not familiar with NPM, they just get installed for you into node modules. And what you get is TNS core modules, so that's Telerik Nativescript core modules. And there's a bunch of them that you get out of the box, including things like location services and connected ways to check your connectivity on your device and that sort of stuff, ways to interact with the file system, and the camera. So the interface that I was talking about, and I noticed earlier on that this particular library is actually deprecated. I think there's a newer version, but I figured I would just show it anyway because it shows the point. And the new one I'm sure is similar. So don't heckle me too much. But you can see that they've basically said there's a facility, there's a method called take picture, and you as a Nativescript developer can go and use that, and it will do what you expect. But under the hood, this interface is satisfied by a Android implementation and an iOS implementation. So in the Android implementation, they've gone and raised an Android intent with various things, just like you would do in standard Android code. And this is kind of interesting because this is Android code written in JavaScript, running in magic. Essentially, what they've done is they've made the native APIs, in this case the Android SDK, they've made that available by running your code inside the V8 framework on the device. So you can write JavaScript code, but all the kind of low-level Android-y stuff or low-level iOS-y stuff is available if you want to get to it. But what's nice is that for the common stuff, like camera and so on, someone has already done it for you. You can just use it, and it's good to go. And there's also a really good website called the plugins.nativescript.org, where there are tons of these things. You can do all kinds of stuff. So here's one for providing NFC capabilities. So you can kind of see how that would grow out as the community build things.
So would that kind of low-level JavaScript get transpiled into Java on Android?
If I'm honest, I don't fully understand it, but no, I don't think so. I think it's basically the V8 engine is able to provide those functions to you, but I've not really worked out how it works. All I know is that you can use JavaScript to access the native APIs, and it seems to work. There is a good blog post on that, which I found earlier on, but I haven't understood it deeply enough to say with any authority how it works. Not going to lie. So that's a little bit about how you can use native capabilities as well, which I thought was kind of powerful because it gives you the capability to write simple cross-platform code, but then where you need something really specific, you can go and dig in and actually write some Android, write some iOS, or get someone who knows how to write some Android and write some iOS to do that for you, in my case. And that's kind of the gist of, I think, most of the parts you would need to know to get started and build something cool. So I thought I'd just finish off with like my view of the pros and cons of this tool. So the pros are it's great cross-platform support, so you can build one piece of code and know that it's going to work pretty well on each of those platforms. You get very high code reuse, as I showed you, between Android and iOS. You get the potential to use your code some of your code, not all of it, probably not the view layer stuff, but the lower level stuff, so like your business logic. If you've got an Angular web app and an Angular or Nativescript, an Angular mobile app, you could I think quite powerfully reuse some of those services. So all the stuff that does your day-to-day business logic or fetching data or whatever, you could just hook that in and pull it into both projects and they'll run the same, which is quite good for a web person. Probably not so much if you really know what you're doing with each platform. For me, it's great because I build for the web and I don't need to think too much. And I like that it gives you the capability to hook into the native life cycles or hook into the native APIs that you might have if you're building a so-called proper app. And also, I haven't really showed you this, but the tooling that you get in, especially if you use VS Code and the extension, the Nativescript extension for that, you get a really good tooling. You get all the good kind of IntelliSense stuff, debugging stuff that make it quite a nice way to build an app. But on the downside, I found it a little bit difficult to set up. That's probably just because I don't know what I'm doing with mobile. So I had to go through the process of setting up my Android environment, my iOS environment, making sure it was all working, which, again, the whole point of this for me was I don't really know how that works. So it took some time for me to get over that. And I also had some problems when I tried to upgrade from one version to the next, because it told me my Cocoa pods were wrong. And I don't know what they are. I don't really care what they are. I'm sure some of you love them. Lifecycle considerations. So if you're an Android guy and you build for Android, fair enough. But with this, you kind of have to know all of the life cycles. You have to know Angular's approach to that, and also Android's approach to that. And you need to know which one to use in which situations, which I found a bit complicated in certain parts. And it also does things with caching. So as you navigate from one view to the next view and then back, it will reuse the same view for performance reasons. And I found that it was a bit difficult to know which lifecycle hooks I could use to reload my page, even when it's coming from a cached view. But that, again, it's probably just because I've not been working with it for long. CSS is a great thing to be able to use, and it's very familiar to me, but I found it was a little bit limiting. So in my case, I wanted to do the shorthand margin option. So I said margin this many, this many, this many, this many, and it didn't know what I was doing. It turns out they only provide margin top, margin left, margin right. So things like that, where it's not necessarily obvious that you can't do it. I thought maybe that was a con, but they could easily improve it as well. And that's the bulk of the content. So I just wanted to finish with a couple of resources that if you want to play with it might be useful. VS Code is a great editor, and there are some good extensions you can get for that. So in this case, Nativescript extension gives you all of the debugging capabilities and so on. There are snippets packs that make it super snappy to go and change things. So let's go to VS Code quickly and say, okay, I want a Nativescript grid, which is 3 by 3, bam, and then you're good. Stuff like that just makes it quite quick and easy to build different bits of your UI. The documentation for Nativescript, in my experience, is very good as well. If you go to nativescript.org, there's a whole bunch of really good tutorials and reference points. So the user interface is a good example. If we go to components, it will list out all of the different components, how you use them, what inputs and outputs they've got and stuff. And it's also a really, really good Angular tutorial, which I thought was quite interesting. It's probably one of the best Angular tutorials I've ever gone through, as a sort of side effect. We have the Nativescript image builder, which is handy. This is just a website. I don't think it's an official thing. I think it's just something that's out there. You can put in an image file and it will give you the right shapes and sizes for each platform, which is handy. What else? The plugins repository I showed you, that's where you can go and get third-party add-ons, if you like. And then finally, there's the theme builder, which is the design folk amongst you. You can say, I want my thing to be pink, and then it will give you a nice style sheet to use, which I didn't bother with, but it's there. Yeah, thanks for listening. Does anyone have any questions? You can ask me or you can tweet me. Hi.
What are the build times like?
Pretty quick, because it does a lot of live reloading stuff. So the first time you run it through, it will take the same sort of time that you'd get if you were doing a normal Android app. But then it will inject any changes to your TypeScript files or your style sheets straight in. So that's quite rapid. And you just save the file and it will change in both emulators at once, which is cool. The exception is if you change the resources. If you add a new image, then you have to stop it and start it and wait for it to build. Yeah. Chris?
If I wanted to use this without Angular, because you said there was an option to not use Angular.
Yeah.
Like, how much more, like, will I be shooting myself in the foot trying to do it that way?
I don't think so. I think it depends whether you think in an Angular style or not.
I've never written Angular.
So if you've never written Angular, then maybe it would make more sense not to use Angular on the first run through. But I found it was a great introduction to Angular. Like I say, if you just go on and run through that tutorial, the data binding goodness that you get from Angular, I think, is worth it.
I wonder how obvious it would be what is Angular and what isn't Angular.
Yeah,
as part of that learning.
That's very true. And also the same thing happens if you're trying to find things on the web about it. You don't necessarily know if a code sample is using the Angular style or the plain style. So that's kind of a downside, actually.
That's a good point.
Yeah.
Do you know of any support for some of the, well, on Android, basically, some of the new pieces of design, so like floating action buttons and things like that? Is that something that they support at the moment, or is it?
That's a good question. I don't know, actually. I kind of don't bother with design. I just stuck some buttons on, and that was good enough for my initial try. If you wanted to do a proper material design, I don't know how well that would go. So I'd be interested if you ever play with it to let me know, because I imagine it's probably doable, but it depends what kind of cross-platform support you want as well. So obviously, if you want it to be full material style on Android versus plain iOS style on the other, then maybe that's where you need to dig into these individual style sheets and change things around. But there is quite a lot of support in the CSS for doing like borders and shading and whatever, that kind of stuff that you would want to make something material, even if it's not in the framework. Yeah. Hi.
Do you find any like gaping holes that haven't been plugged yet? In the kind of brief look around with them, big missing pieces of functionality that people are working on, or is it a pretty complete framework?
I haven't gone to much depth, so I would consider the app that I built there to be fairly basic in terms of it's just fetching some data and putting it on the page. So I didn't really get into things like where you're doing stuff with the hardware in any particular way. And actually, if you want to do really high performance stuff, then it's probably not the framework for you anyway. But the only thing that I found that frustrated me was with the Firebase plugin. There's a Firebase plugin called Angular Fire, which is for use on the web. And I wanted to use that originally. And I found that because it was kind of dependent on the DOM, I think was the reason. It didn't allow me to just pull that in and use it like I would in a web app. So luckily in this case, there is also a Nativescript Firebase plugin, which is quite good. So I use that. But,
So you're not able to use like Angular plugins per se. You have to get the Nativescript modified version of those plugins.
if it's doing particular things, like I think Firebase hooks into Google Play services and stuff like that. So it's kind of a little bit more low level than some of the others. But I did successfully use Moment. So it renders formats the dates with Moment. And the little icons you saw were a library called Font Awesome, which I use on the web as well. So if it's a fairly simple NPM package, you can just pull it in and use it, no problem. But I think where it interacts with the DOM or uses low level stuff, you might find a bit more mileage might vary. Chris again.
Yes, sorry. Can you go back
No,
to your
thanks.
pros and cons list? What I'm quite interested here is where, for example, the flexibility used in native APIs is a pro in this case. Clearly, that's a good reason to use this. The other ones that you showed at the start, the different ways you can build a mobile app, do lots of them have that ability? Is this quite a unique thing for Nativescript?
Well, if we look at, for example, Cordova, right? Cordova, which is a web view style technology. So you're building something that looks like a native app, but actually it's a web page. And that does a similar trick with the plugins where they write these native implementations, and then they go through a magic portal, which takes it into your JavaScript side. And I imagine it's quite a similar experience to that in terms of using the native capabilities or whatever. But what I like about this is you don't have to have that magic tool because the JavaScript is running natively on the device, so the performance is theoretically better. And they've done some good demos, like they had a demo of like 100,000 things in a list, and they used there's a list view component which will do the caching stuff, so you can spin through it really quickly, which if you tried to do that in Ionic, I imagine it would not go so well.
I've heard that things like Cordova and PhoneGap, it's difficult to get those actually into the stores, particularly the Apple Store, because they're obviously not a native app and they don't like them so much.
Yeah, and your users are going to feel alienated if it doesn't feel right, which
Yeah.
is why I like something like this where it's building actual Android buttons, because it looks and feels like it. You wouldn't know as a user.
I suppose you probably don't know the answer to this, but I wonder whether this stands a better chance of going through those checks than say Cordova app would.
I imagine it would, because they wouldn't be able to tell it was built with Nativescript. All they see is a native project.
So another pro for you.
It's another pro. Yeah. Jimmy.
Can you get access to the underlying projects? So is there could you?
Yes. So open source, I believe. So let's go to.
Oh, sorry, no, I meant the underlying Android project. So you could literally.
I thought you meant the plugins, right? Also, yes. So you mean like the camera plugin, for example, or?
No, I mean as in
Generated app.
yeah, the generated
Okay.
source code.
Sorry, I was just like, yes, you can. So in the platforms folder, you get the native project, and in here we have all of the stuff you'd expect. So,
But you don't usually edit that, do you? You edit the delta.
You edit the delta normally, but you can go in there and you can see it. I wouldn't, in my experience, I wouldn't recommend touching that folder because most of the time it's going to end up pain.
All I was thinking was from point of view that if later on down the line you decide to use something else, you could always take that out if you've got access to it. Or you could port to something else.
It'd be interesting to see what it generates though.
So Jamie, as an Android dev, is this folder basically what you would create for an Android app?
The structure, yeah.
So I'm lost because I've zoomed my screen in so far. So you get a normal manifest file which will look familiar to you. You get some JavaScript which I've not actually looked at before, so this will be interesting. But it looks like Java. So yeah, I presume you could probably go and use that, but I haven't tried. I'm not sure I'm man enough to try it.
Have you looked at all at React related? And if you have,
I've seen it, but I haven't tried it. So
difficult, you have to sort of compare the zero thing.
yeah, I mean,
This
right.
looks better.
Yeah, the rest of that.
I like the look of this. I
Okay.
didn't like React Native. Well, the modules, in my eyes, weren't ready for people to use. I like the fact that this actually has an official component store. That's fantastic because React Native has 5-10 different random places on the internet to go and get components from. Yeah, it just seems the Delta approach is really good. The fact that if you want to do native development or to make native changes, you put it in the Delta part and then it gets folded into the main code. With React Native, you just get in there, just ram your hands in it and hope it doesn't destroy everything.
I imagine as the platform moves on, that approach would get a bit messy.
It will do, yeah. But they've got a similar approach from what I've just seen in here. They've got one activity and then all the magic happens in that one activity. So if you open up the manifest, yeah, you've got that one Nativescript activity and that's where everything's been, all the views are being put onto it and taken off of it. So similar in approach.
In terms of IDEs, what's this again? Visual Studio, is this?
This is Visual Studio Code. Yeah.
Yeah, is that the kind of consensus on what?
It
you
seems to
tend
be the one
use?
that the Nativescript team have focused on. So when you go on the documentation, the tutorials, all that stuff, it's kind of just saying, hey, get this, it's free, it's great. There's a really good plugin for it as well. There's nothing to stop you using whatever editor you want. So if Atom's your thing, sure. But I don't imagine you get the same plugins out of
PHP Storm.
Probably not so great with PHP Storm, but PHP Storm again is it's not a mile away from WebStorm, which would be pretty good for this. So yeah, I think that's the one they've focused on. It's the one that I use just because I like it anyway. I think the only thing I don't like about VS Code is the name because it gives people this kind of reaction. Well, it's Visual Studio, I don't like it. It's really not Visual Studio at all. They should have called it like something really hipster, and then it would be a great thing, and everyone would love it. Yeah. Any other questions?
Were you able to share your slides and projects?
Sure. Yeah, I can do that.
That's your source code for.
Yeah, I'll if you watch my Twitter, I'll put it on there or something. I'll give it to these guys. Thanks for listening.
Cool. Thank you.